So our today's topic is fluid pressure. Fluid pressure. Liquids and gases are together known as fluids. They exert pressure on all bodies immersed in them and on the walls of the containers that hold them. When an object is immersed in a liquid, it exerts a net upward force on the object. Means the liquid or fluid exerts an opposite force on the object. For example, if I am pushing a balloon inside water, I am pushing it downwards, the water will push it upwards. So here we can see two bottles. Let's first see the first bottle. So in this we can see three holes are made in a bottle and water is filled in it. So let's take these holes as A, B, C. Okay, so in hole A, the water is moving normally, like means it is not moving very fast. Why? Because the pressure and weight of these two layers are falling on the third layer, that is which has the hole A. Now let's see the hole B. The hole B is moving a bit faster than the hole A. Hole A is water, right? So why is this so? This is so because the pressure and weight of these all layers, that are all these 5 layers, is coming on the 6th layer, which has the hole B, right? So same thing in the hole C. Hole C is the fastest, has the fastest running water. Why is this so? Because the weight of this whole water that is above it, weight and pressure is falling on this layer, and this layer has a hole, so it is moving faster. If here one more hole would be there, it would almost move in a straight line, because it has the most pressure of the whole bottle. So by seeing this picture, we conclude that liquid pressure increases with depth. In the second picture, we can see that the holes are there in all the directions and the water is moving in same speed. So this picture proves that liquid exerts equal pressure in all directions, right? So let's see some examples of fluid pressure. If you try to push an inflated balloon into a bucket of water, you will find that as you try to push it down, the balloon, the water seems to be pushing it back upward. So this is the opposite force by the water. If you stop pushing the balloon, it will be pushed back to the surface. This is because the water in the bucket exerts pressure on the balloon. The upward force exerted by the liquid determines whether the object will float or sink. Now, if the object is very heavy, so the force exerted by liquid will become less, and so the force exerted by the heavy object will be more and the object will sink. So, measuring pressure. The general term used for an instrument used to measure pressure is a pressure gauge. Pressure gauge is a very simple term used for measuring pressure. Now, a very simple type of pressure gauge is an open tube manometer. Now, let's see how the open tube manometer actually works. So, here is a U-shaped tube and here is also a U-shaped tube. So, let's see the first tube. Here in the U-shaped tube, one should be left open, and because of the atmospheric pressure put in here, and one is connected to another tube, and let's say it is connected to a liquid surface or a glass or a bucket of water. Inside that the tube is kept. Make sure that the water does not flow back into the tube, otherwise your experiment will not work. So I have attached a tube here, and then I have kept it into a bucket. So now what happens is, we can do vice versa also. If you open keep open the this side's tube, you can attach the one more tube to this side. So here in this picture, they have attached the tube at the right side. So now I have attached the tube at right side into a bucket of water. So here the water is going down and the water is going up here. What is happening? The thing happening here is, the pressure of water is pressing the water here, and then we can measure the pressure difference by the scale also, that the pressure, the both the sides here the pressure was equal, and when we are measuring the pressure from this side, we can see that the pressure is not equal. So variation of liquid pressure with depth, as we saw, the liquid pressure increases with depth, right? So pressure exerted at a point under a liquid is more due to the weight of the liquid above it. Therefore, as we go beneath the surface of the liquid, the pressure increases. Deep under the sea, the pressure exerted by water is much greater than at the sea level. That's why the deep sea divers have to wear special suits called diving suits and buoyancy compensators to combat the weight of their diving equipment and water pressure at great depths. One more example of liquid pressure increases with depth can be, dams are made stronger and thicker than at the bottom, than at the top, to withstand the high pressures at great depth.